Hello and welcome to today's webinar. In the next 30 minutes or so, we'll be looking into detail on the subject of data integrity for materials testing. With some practical information before we dive into data integrity, the webinar will be recorded. All participants are muted. If you wish to ask a question, please go ahead using the chat function at any time. If I can, I'll try and answer as we go through the presentation. Otherwise, we'll answer questions at the end. We will also share the slides, which we'll send to you by email. And once the webinar is recorded, you'll be able to access it from our website and our YouTube channel. So I'll be presenting today. My name is Toby Rogers. I'm the Sales Director at AMETEK Test. I have 30 years experience in materials testing, and I spent much of that time also working with my colleagues in AMETEK STC on data integrity, particularly in the medical device industry. So, quick review of the agenda today. So we'll have a quick look at who are AMETEK STC, and we'll look at some of the typical applications in materials testing that require data integrity. We'll then go into the data integrity itself and also how it relates to FDA 21 CFR Part 11, which is the key regulation governing the whole subject. Once we've looked at the background and what it is and why it's needed, we'll look at some of the key features that you need to look for in an application software that will help you ensure that the integrity of your data. And all through this, we'll be showing the features and explaining them using real-life example. In this test, we'll be looking at testing the glide force of a syringe. And we'll actually go through beginning to end how we set up the software for data integrity, and also we'll be looking at the data when it's captured, electronic signatures and audit trail and so on, to put everything into context. So who are AMETEK? AMETEK, I believe, is around $6 billion today, continuously growing. And we have almost 20,000 employees globally. And AMETEK STC is one of the many businesses within AMETEK, and we are focused on materials testing, force measurement, with a particular focus on medical devices and pharmaceutical. AMETEK Test, as I mentioned, is part of the $6 billion organization focused on materials testing. So just to give you an idea, here we have a tensile compression testing machine, which in this example here is being used to push some tablets through a blister pack. So it's that kind of testing that we're going to be focused on, pulling, pushing, whether it's blister packs, syringes, and so on. So that really the typical applications where data integrity is critical are syringe forces, syringe glide force, the pull-out force of needles, bending needles, and then a lot of focus on medical packaging, particularly the seal strength, to ensure the integrity of packaging can all be tested on the same machines. As I mentioned today in the worked example, we're going to be focusing more on the syringe glide force. One of the key things in data integrity in the medical device environment is FDA regulation 21 CFR Part 11. The concept of it is very simple. the regulation is defining the regulations for the conditions under which regulated companies can submit electronic records in lieu of signed paper documents. So historically, data integrity was extremely paper intensive, a lot of signed reports and so on. And obviously, in the medical device industry, the retention period can be extremely long, and you can amass an enormous amount of paper. Not only is it environmentally unfriendly, the biggest issue is actually if you do need to look back in that history, it's a very laborious process to sift through years and years worth of paper. So it's complex to manage paper documents. So really what they're saying here is we're going to define some regulations where you can create the data electronically and store it electronically and still maintain the integrity of a piece of paper with a physical signature on it. And in fact, as we go through, you'll see that those regulations are in reality far stronger, give far stronger data integrity than the old paper document system. One of the key points to remember is that an organization becomes compliant to 21 CFR Part 11. A software itself is not compliant. A software is just one piece of the jigsaw to obtain compliance. It's your organization that will become compliant. And it really is a combination of the application software, your organization's policies, procedures, and IT configuration. So all of those come together to allow compliance. So in this meeting, we're going to focus on the application software. Obviously, we provide some consultancy support to explain what our software can do. And then together with your IT organization, we can go through what we have in the software. You can look at your IT procedures, and then really we give you information for you to decide on your compliance. Let's start with the basics in, what is data integrity? So data integrity refers to the completeness, consistency, and accuracy of data. Complete, consistent, and accurate data should be attributable, legible, contemporaneously recorded, original, and accurate, and that's often abbreviated to ALCOA. And it really boils down to what happened, when did it happen, where did it happen, by who, and why did they do it. So we've got an example below of an audit record from our application software, which gives the full name of the user, which is an electronic signature. So we know who did it, but we also need some controls in the background to ensure that this is, for example, not a free text field. This is actually something where the data integrity is secured, and we'll see as we go through how we achieve that. We've got date and time. We've got the time zone of when that action was taken. We have got the reason why it happened, and then importantly, we've got a description here of what actually happened. So this value changed from false to true. And we'll go through this in more detail. But really, we're trying to get to what happened, when, where, who did it, and why, and have a lot of controls in the background to ensure that each one of these is accurately stored and also, very importantly, cannot be modified. So those principles that we mentioned, attributable, simple, who created a record and when did they do it? Legible, again, very simple. Is it in human readable form? Contemporaneous, is the data recorded in real time as it happens? We want to make sure they're not recording the data long after the event. We need to make sure that the source data is original and accessible. And we've got to make sure that that data is complete and reliable. So these are the base principles of the data integrity. There are some further important principles available. Is the data available for the lifetime of the record? So it could be 10 years, could be 15 years. So we'll work with the IT team to work on, for instance, archiving and backup. Enduring, is it available for that particular amount of time that's needed in that application? Consistent is a critical one, is have all the elements and data files been stamped in the expected sequence? And complete is to make sure that there's an audit trail that shows that no data has been deleted or lost. So once we've captured all this data, we've got to make sure that that data is unable to be deleted, cannot be changed. So those are the data integrity principles that will just give some background onto some of the features that we have and why they're there. There are some key features that we would look for in a software for data integrity. The first one is to separate the administration of the system settings, the user management and permissions from those who actually perform the tests. So a critical part of 21 CFR Part 11 is to make sure that the manager of the system, who can add and remove users and decide what permission levels people have, are not the same people as those performing the tests. Again, we're looking at data integrity. And if those performing the tests have access to the user management and permissions, then it's a challenge to be able to believe in the data. So we'll see later that the Nexigen Plus software has features in there to ensure that we separate these features. The next one is to identify the user. But we actually use Active Directory user management. Active Directory is basically your Windows login, your corporate Windows login. And by using that, we can be sure that only you signed in and signed off on work. So it also reduces a lot of the validation effort, because a third of the 21 CFR Part 11 is ensuring things such as the length and complexity of passwords, how often users need to change them. And since we are piggybacking off the Active Directory, obviously your corporate system will be compliant anyway, so there's no need to then validate that aspect of 21 CFR Part 11. Another key aspect is to be able to create user groups so that a user can belong to a group, and each group has their permissions locked down to the bare minimum. So just like the Japanese, in data integrity, the key thing is not to detect things have gone wrong, but to stop it going wrong in the first place. So restrict people's access to make changes, deletes, and so on. So it's a critical part. The next part is electronic signatures. We'll look at electronic signatures in a little bit more detail in a moment, but those are required in a software for authorizing changes and signing off on any work that's performed. Once we've done all of that work, then we need to have a detailed audit trail. And again, we'll look at more detail at an audit trail, but it's going to contain, information on changes to the system, i.e. a log of any users that are added or removed, any changes to permissions, through to test method approvals and logs of any work that's been performed. And lastly, we need to make sure that that data is tamper-proofed, stored securely. And typically, we would use, for example, an SQL database, which most corporate organizations have their own secure system to manage SQL data. Active Directory user management is something we mentioned. Then user creation is controlled by a company's IT policy. So, when a new employee joins, typically their identity is checked and so on. And once that's been done, they can be added into the Active Directory system. So effectively, only users that have gone through that process of being added to the company Active Directory can be added to Nexigen Plus software. It also means that if an employee, for example, leaves the company and their Active Directory account, their Windows account has been automatically removed, then effectively that account is removed from the Nexigen Plus automatically. There's no independent process required to manage the Nexigen Plus. We mentioned earlier the password complexity and change intervals will automatically comply with corporate policy. So if there are any changes from a corporate perspective, they will just roll through into the Nexigen Plus without any action needing to be taken. And that means that there's no independent user management system to manage. And the users, it makes life simple because they will only need their usual Windows credentials to perform their work. They won't have an additional login, username, and password to remember. So it's critical that we separate the functions within the system. So, for example, we would have an IT admin group who perform user management groups and permissions, which is typical of all software in a corporate organization. And that IT admin group doesn't have access to create test methods or perform any work. In that aspect, we would then have supervisors in the system who are there to create methods and report templates. And we may have some analysts who perform tests. And then we may have some reviewers who review work and approve the test runs. And those groups 2, 3, and 4 have no access to group 1. So we're splitting the management of the system from the use of the system. So that's a critical thing to look for in a software. So that's enough slides for now. Let's actually have a look at a real example using the Nexigen Plus software. What we're going to do here is open the administration system, we call the security module of the Nexigen Plus. And the first thing that will happen is we have this login, which is the standard Windows request for an administrator. So only an administrator can log into here. So effectively, only IT can access this system. And in here, we set up the SQL server where we're storing the user management data and also the audit trail. And then the IT department have the ability here to add and remove groups and add and remove users to groups and manage the permissions for each group. So for example, here we have the analysts group, and we can see that only a small number of checkboxes in there, and we've effectively restricted them to the bare minimum they need to function. And we have a reviewer group where they are allowed to open the existing work and review it, but they can't perform any tests themselves. And then we have, for an example here, a supervisor group who would typically be creating test methods. They're just 3 example groups that we supply. You can modify each group. You can add and remove new ones. So what we've done there is set up our users. Once the users are set up, we're going to start using the software. And one of the key things you'll see in the worked example in a moment is electronic signatures. And in this instance, an electronic signature is a unique combination of username and password. And this is your Windows username and password. And entering this is unique. Nobody else knows the password, so we can be very sure of the data integrity, that the person that signed is the person that actually did the work. So this gives excellent traceability. And one of the things that typically we will do is once we make a change in the software, the user is forced to enter the reason why that change was made, and then they're asked to sign off, and that becomes a secure signature. And while we're doing all this work in the background, we're creating a detailed audit trail. Some of the things that we're going to look for in an audit trail are making sure we log the configuration changes, and it's also critical to log the before and after values of any change. We're logging changes to user management and permissions. We've got detailed timestamps, including time zones. The full name of the user responsible is effectively their electronic signature. We have in the software reasons for changes. If a test is aborted, the user will be prompted to enter a reason and then to electronically sign. Also critical is a log of any failed login attempts in the software. And last of all, we need to keep that data secure. So it's secured securely in an SQL database, which your local IT will be able to manage. So we've created the users in the system, and what we're going to do now is log in as a supervisor, and actually we're going to create a test method. So when the user is opening the software, first thing we need to do is log in using our Windows credentials. The audit trail then knows the exact identity of the person that's logged into the software. And what we're going to do here for simplicity is we're just going to make a small modification to an existing test method and see how that can be securely deployed. So we're going to edit this test method, and we're going to change this parameter from 1 to 2. When we press OK, first thing we need is to enter the reason why we did that. So it could be a webinar, it could actually be an ID number. We're then going to electronically sign. So I've electronically signed to say that I made that change. And I'm then going to approve that test method. The analysts can only perform tests that have been approved. So I'm going to approve it. So I've put my electronic signature to actually deploy that test method to the analysts. And I'm also putting a reason in there for that approval. And effectively now we're saving it as a template. So this is an approved test method template, and the analysts can create new tests that use exactly this configuration. And in the background, we've got a detailed audit trail. We can see here the name of the person, and we can say it changed from 1 to 2. We've got the date, time zone, location of the file. And we've got a lot of other information in there. That here we're logging that the test setup was approved. We've got the electronic signature, the person that did it. Effectively there, we've configured our test method, and we've ensured that there's traceability on any changes and reasons for that test method. So now we've got the test method, what we can do is we can actually perform some tests. So what we're going to do now is we're going to log in as an analyst, and we're actually going to do some syringe tests. So we're going to log in with our Windows credentials. Bear with me, I think that's the previous one. Yeah, so now we're logging in as an analyst. And the analyst is only allowed to perform tests using an approved test method. So we're going to create a new file from templates. And here we have our Glideforce template that's been approved. Start the test. We're performing a test, compressing the syringe. The test is completed. We've got the results here. The analyst has decided to approve that test run, and the analyst is now signing off and added their electronic signature using their Windows credentials, and that will all be stored in the audit trail. We have a lot more information in the audit trail, so we've got the full name of the user here. That's the electronic signature. We've got the test results. We've got details of the software version, the machine serial number, the load cell serial number. So what we've got in there is a lot of traceability on to prove the accuracy of the data. Here we've got the information on who approved the test method that was used. And if we look in the audit trail, then here we can see detail of the person that logged in. When they logged out, they created a new file from the template. So there's full traceability on where that data came from. The last step is to print a report, for instance. So the software will print directly to PDF, and we can have a report with a lot of data integrity features in there. So we've got the timestamp, we've got the electronic signature of who approved the results. Graph in this instance. And then we've got some important information. So we've got a log here of who actually printed the report based on who was logged in at the time. We've got a log of who approved the method and when. And we've got an electronic signature here of the person that actually reviewed that data and signed off. And then at the bottom here, we've got some information, traceability, which can track back to the load cell and the calibration, so we can ensure the accuracy of the data. That's the end of the worked example. So in summary, really, we're looking at what happened, when, where, by who, and why. And we want to look for features such as method approval. We need electronic signatures, Active Directory integration. Audit trails are absolutely critical with before and after values. And then we've got to make sure that the data is stored in a way that is secure, it's tamper-proof, and it can endure the lifetime that it's needed to last. Obviously, there's a lot involved in there. And as I mentioned earlier, 21 CFR is an interaction between the software plus an organization's IT policy and procedures and so on. So really, it's very important to work with a partner with solid technical support and understanding of data integrity, because it really is a detailed joint effort. And we have many specialists around the world who can work with customers to understand how 21 CFR Part 11 compliance can be achieved. So that's the end of the seminar today. Hello and welcome to today's webinar.